Okay, good morning. It's been a while since I've seen you, so I'm going to do a brief overview of objectives 1 and 2 before we get into objective 3 for section 5.2. Okay, so again, 5.2 was called the addition rule and complements. So the three objectives overall for this section were to use the addition rule for disjoint events, to use the general addition rule, and to compute the probability of an event using the complement rule. So the complement rule is the one that we're really going to concentrate on today. But again, brief overview of objectives 1 and 2 again, just to kind of catch you up and get you back into the swing of things here. So for objective 1, we use the addition rule for something called disjoint events. So two events are disjoint if they have no outcomes in common. Another name for disjoint events is mutually exclusive events. Hey, and I think the example that I was using during class is if I toss a coin, I can get a heads or a tails, and then I roll a die, I get a 1, 2, 3, 4, 5, or a 6. In no way does one have anything to do with the other. So those are mutually exclusive. And any time that you have mutually exclusive events, you're going to add the two probabilities together. So the probability of event E or F is going to be the probability of E plus the probability of F. We also took that one step further and said you didn't have to have just two events. You could have more than two events. And as long as all those events were disjoint, you just keep adding all the probabilities together. Okay, so there is no limit on how many times you can add together your probabilities here. Okay, and then for objective 2, what happened was we had something that ended up overlapping. So objective 2 was to use the general addition rule, and what happened this time, for any two events E and F, if there is something that overlaps, you're going to take the probability of E, add the probability of F, and then subtract out the probability of E and F, that part where they overlap. So the one example that we did, we looked at a deck of cards. And again, here's your picture of your deck of cards. And then we wanted to decide what was the probability of drawing a king. Okay, that one, 2, 3, 4, straightforward. That was 4 out of 52. Then I wanted to know the probability of drawing a queen, a king, or a jack. Again, it's not possible for something to be a king and a queen at the same time, or a king and a jack at the same time. So again, they're disjoint events. So again, I just added my 4 jacks, my 4 queens, and my 4 kings together. And that one gave us an answer of 12 out of 52. Okay, and then for the last one, we wanted the probability of drawing an ace or a heart. Okay, so again, our hearts were all in this row right here. And then our aces were here. But this time around, I do have something where they overlap. I'm counting that ace of hearts 2 times. I'm counting it once when I count my hearts and once when I count my aces. So again, the first thing I did was count my hearts. So altogether, there's going to be 13 hearts in the deck. Okay, plus my 4 aces, but I'm going to get rid of that one that I double counted. So 13 plus 4 was 17, and 17 minus 1 gave me an answer of 16. So that one was 16 out of 52. So you just have to remember to get rid of anything that you might have double counted. Okay, so for objective 3, we're going to compute the probability of an event using something called the complement rule. So the complement of an event. So let S denote the sample space of a probability experiment and let E denote the event. The complement of E is denoted E to the C power. Okay, this is all the outcomes in the sample space S that are not outcomes in event E. So the complement rule. Okay, if E represents any event and E to the C power represents the complement of E, then here's what's going to happen. The probability of the complement of the event is going to be 1 minus the probability of the event. Okay, and again, kind of a picture of what's going on here. If you have event E in green, then the complement of that is going to be everything outside of that. Okay, so it might help if we look at an example here. So according to the American Veterinary Medical Association, 31.6% of American households own a dog. So what is the probability that a randomly selected household does not own a dog? Okay, again, we're going to do the complement here. So the probability that they do not own a dog is going to equal 1 minus the probability that they do own a dog. So again, I just changed that 31.6% to a decimal, and I did 1 minus 0.316. And when you do that, you're going to get 0.684, or again, if you wanted to change that back to a percent, it would be 68.4%. Doesn't really matter if you put it in percent form or decimal form. Really, as we get further into this chapter, the next chapter, chapter 7, most of the time we're going to be looking at them as decimals, but I know sometimes it's kind of easier to look at them as percents. Okay, so the data on the right represents the travel time to work residents of Hartford County, Connecticut. What is the probability that a randomly selected resident has a travel time of 90 or more minutes? Okay, so in this case, this one's going to be straightforward. There is my 90 or more minutes. So my top is going to be 4,895. And then I'm going to have to get my total number here. And to do that, I'm going to have to add straight down my frequency column. So when you do that, you are going to get an answer of 393,186. So the probability that a randomly selected resident has a travel time of 90 or more minutes is going to be 4,895 out of that 393,186. So again, I just added straight down that frequency column to get that. And then again, I pulled in that 4,895 for my numerator. And on the slide, the last thing that I did was divide to get that as a decimal. So 0.012. Okay, so now let's take this and use the complement. So now let's say I want to compute the probability of a randomly selected resident of Hartford County, Connecticut will have a commute time of less than 90 minutes. Now, less than 90 minutes, I can sit here and I can re-add all of these numbers together with everything except that last one. Okay, or because now I know what the complement is, the probability that you have a commute that's less than 90 minutes is going to equal 1 minus the probability that you have a commute that's more than 90 minutes. So again, we found that on the last slide. That was our answer from the last slide. So if I just take 1 and subtract out that 0.012, you're going to get an answer of 0.988. And that's as simple as the complement is going to get. Okay, so again, later on today, this is all going to go up on Google Classroom, but later on today, again, please don't forget to fill out the Google form. And then also you're going to have to complete this textbook assignment and hand that in as well. And everything will be up on Google Classroom. Have a good day, guys. Stay warm.